Hello and welcome to our new episode of 2D top-down game tutorial, and today we will be talking about the inventory and how to implement the drag and drop feature. After this episode we will be able to drag apples or items between the inventory slots and also drop the items back to the game. So let's start by opening the inventory slot widget, and we will switch to the graph mode there. Here we will click on the override drop-down menu in the functions section, and we will choose the on preview mouse button down. This function is called when the player presses the mouse button on the widget, and the preview in the name means that it's a tunnel version of this event. So if you want to know more, Google for tunnel versus bubble events and you will find out. I will not cover this here. So we want to check whether the player drags the inventory slot here. So let's add the detect dragged if pressed action, connect it to mouse event, and the return value should be connected to the return value of the function. And we also need to set a drag key to the left mouse button. So next we will override the OnDrag detected action. So click on the override button, search for the OnDrag detected, and here we will simply print some debug string to check whether everything works correctly. So add the print string and write the drag detected string there. We can start the game now and try to drag something from the inventory slot, and you can see that the drag detected string is written there. The issue is that it's also written there for slots which are empty, so let's fix it. To do that, we will have to access the inventory from the inventory slot widget. So let's add new variable there called inventory, and we will set the type to inventory, VPC inventory, and object reference. We will set this inventory variable in the inventory component. So let's open it and go to the initialize inventory. We will make some space there after the for each loop, and we will cast the array element to the inventory slot widget, because we are actually iterating over the slot widgets here, and create additional space for the set inventory action. Now we can draw the line from the inventory slot widget and add the set inventory action. As an inventory, we will use this self reference because we are actually in that inventory component, and we can connect all those actions together using the white lines so they are executed. We can hit the compile button and we see that there is an error. It complains that the inventory is not found in the inventory slot, and that's because we forgot to compile the inventory slot. So we have to recompile inventory slot and also the inventory, and it will work now. We can go back to the inventory slot widget to the OnDrag detected function, and our goal here will be to detect if something is in this slot and run the print string only if really there is something. At first we need the inventory and use the get items action, and use the get action there to get the particular item associated with that inventory slot. This get action needs an index of this inventory slot, so we can get it by using the get parent, which will actually get the horizontal box where the inventory slot widget is stored at, and we will use the get child index function to get the index of this slot in this horizontal box. So we will use the self-reference as a content variable. This piece of code will be used a lot, so we can select it and collapse it to function to create new function from it. We can name the function get slot index and open it, and when we open we can click on the function again and scroll down to the output section and add new output. The type should be integer and the name can be index. This will be the index of the slot we will return from this function. The return node appears, and we can just connect the return value of the get child index action to the return node, and we are done in this function. Now go back to the OnDrag detected, and we will call this get slot index action as a first action in this function. So move it there and connect it to the OnDrag detected and on the print string action. Now we have the index of the slot, so we can connect it to the get action, and this will actually return our item associated with this slot. And because we will use this a lot, we will also collapse it to function and name the function as get slot item. We will open this function and click on it again, so we can add new output variable. We will name it item, and the type of this variable will be as item structure. For the input variable, we actually don't need it, so remove it because we will call the getSlotIndex directly from this function. So let's make space for it and get the getSlotIndex there and call it from the getSlotItem and connect the index to the getAction. Now we also have to set the return value and call the return node, and we are also done in this new function. Now let's go back to the OnDragDetected and see what we can do there. So instead of getSlotIndex, we can actually use the getSlotItem. So remove the getSlotIndex, get the getSlotItem there and call it. And we now have the item representing this slot. We can split the struct pin and add new condition to find out whether there is something in the item. So draw a line from the item name and search for the isEmpty action, and also add a branch action connected to this as a condition. And again, if there is something in the item, the name is not empty, so we will connect the false branch, false part to the print string. We can run the game now and try to drag some empty slot, and we see that the print string is not run. And if we add the apple there, the drag detected string is shown, so that works as expected. So we can detect the drag event, and now it's a time to really start the drag and drop action. To do that, let's go to the inventory folder and create new blueprint class, and the type should be drag and drop operation. We will name it BP_inventory drag drop. This blueprint will contain all the variables we need for the context of the drag and drop operation. So the first variable to add is the from slot variable, and the type should be inventory slot, and we will use it to find out from which slot we are drag and dropping the item. And the another one is the item, and the type of this variable should be our asItem structure. We also need both variables to be instance editable and expose on spawn, so we can set their values when creating this action in a blueprint. To start the drag and drop operation, we will also need a widget, which will be shown under the mouse pointer when we are dragging. So in that inventory folder, let's create new widget blueprint and choose the user widget and name it WB dragged item. In this widget, we only need to show the image we are dragging. So let's add the size box so we can specify the size of this image and set the width and height to 100 pixels. Then we change the view from the fill screen to desired on screen to really show the right size, and add the image into the size box. As the last thing, we can rename the image to the item, and we are done in the widget. Now we have everything to really start the drag operation, so let's go to the inventory slot in that drag detected function and start adding more actions there. We will use the item structure a lot, so let's recombine the getSlotItem return variable back to item and promote it to local variable. Don't forget to connect it using the white lines, and we also have to name the variable as item. Let's get the variable now and use its split struct pin feature to get the name of this variable, and we can connect the name to the isEmpty string action, so the code works again after this reorganization. Now we will also delete the print string because we don't need it anymore, and we will create our dragged item widget. So let's use the create widget action, connect it to the false part of a branch, and the widget will be WB dragged item. This create widget function needs one input variable, which is owning player, so let's use the get player controller to get the owning player controller. Now we can take the return value of our dragged item widget and get its item object, which is the image of the item we are dragging. And we will use the set brush action as in the previous episode to set new image there. The set brush action needs a brush, so we will make the brush using the make brush from sprite action, and we will create new brush from item flipbook. So let's drag the item variable there and use the split struct pin again. Now we can take the flipbook and use the get sprite at frame action to get the first image from that animation, and we are doing that to actually convert that animation to static image so we can use it as a brush. Connect the return value to the sprite and we can move on to next action. Now we have to create the drag and drop operation. So let's right click and search for the create drag and drop operation and find some place for it because it's huge. Connect it to return node and also to set brush and set the class to our inventory drag drop. Now right click on it and set the refresh nodes to reorder the items in the right order. And we can set the from slot variable, and because we are just working in the inventory slot, we will use the self reference. For item variable, we will get our sItem structure and set it there. The last variable is the default drag visual, and we will use our dragged item widget variable there. So let's connect its return node to default drag visual and make the lines nicer. Now hit the compile button and we can try starting the game. And if we do that, we can see that we can drag the apple and we are one step closer to our goal. Now we can go to the inventory slot widget and we'll be working on the drop action. So let's override the onDrop function and add new actions there. The onDrop function has multiple variables, but the most important one is the operation, and it's the reference to our drag drop operation we have created earlier. So let's cast it to that inventory drag and drop operation and call this cast action. In this onDrop function, we have two inventory slot widgets. The first one is stored in the inventory drag drop operation as a from slot variable. The second one is the inventory slot we are just editing. And we want to swap the items in these two slots. So let's start by adding the line from the inventory drag drop operation and get the from slot. And in this slot, we want to get the slot index because that's important for swapping the items in this slot. Now we also want to get the slot index of this inventory slot widget. So find it in the left menu and drag and drop it there and call it from the previous get slot index. Now we will use the swap array elements action to swap the items in the inventory slots by the indexes. So connect it to the get slot index and connect one index there and also second index there. Make the lines a little bit nicer. And as an array in this swap action, we will use the items from the inventory. So let's get the inventory, let's get the items array and connect it to the array input in the swap array elements. As the last thing, we have to refresh items in the inventory component, otherwise the inventory slot widgets wouldn't be updated. So let's get the inventory and call its refresh inventory. Then connect it to the swap array elements and to the return node, and in the return node we have to check the return value, which means that the drop action is actually successful all the time. Now we can try the game and we can see that we can drop item between the slots. But there is an issue. If we have something in a non-first slot and we take an item, it's not updating the existing item but adds new one there, and also like merging multiple items together is not possible. To fix that, we have to go to the inventory component. So let's open VPC inventory and go to the AddToInventory function. To remind you what this function does, we are using the for each loop to iterate over all the items in the inventory from left to right. And if we find some empty space, we will add new item there. But if we drag and drop the apple to the last inventory slot, then the first empty slot we will find is actually the first slot in inventory, and instead of updating the apple in the last slot, we will add new item into the first slot. We therefore have to change the logic of this code a little bit. Instead of doing all the changes directly in the for each loop, we will just note where the free slot is, and we will just note where the item with the same name is, and we will do the changes after the for each loop. That way we can go over all the items in the inventory and we will never miss the item with the same name. So let's add two new variables there. The first one will be called free slot index, and we will set the type to integer. And the second one will be called slot with item index, and we will keep the variable set to integer. In the right menu, we will set the default value to -1 for both variables, and this will mean that we didn't find any slot. Now in the true part of a branch where we check if the inventory slot is empty, we will disconnect it from the set array element, and instead we will just add the current index into the free slot index. So we will just note that the current index is free. So drop the free slot index there, use the set, and get the current index and set it as a value to this set free slot index action. We will do the very same thing in the other branch we have there, which checks whether the item in the slot has the same name as the item we are just adding there. So disconnect it from the set members in sItem and make some space there. And instead of changing the inventory right there, we will just note the index value in the slot with item index variable. So drop it there, connect it to the getCurrentIndex, and we are done in this part. Now go to the for each loop and we will be working in the completed part of this. So remove the return node and we will at first check slot with item index. If there is the item with the same name in the inventory, the value of this variable will be greater or equal 0, otherwise it will be -1. So let's add the greater equal action and connect it to the branch. And we want to call the branch from the completed part of the for each loop. We should make some space there, so let's move things a little bit down, and we will get the original code which we called in this situation, so it's this one, and we will also call it in the newly created branch. But at first we have to check the variables there, because we have the current item variable there, which is not defined anywhere here, it's only defined in the for each loop. So we have to define it, and the current item will be actually equal to the item we have in that slot with item index. So let's get the items array, and in that items array we will use the get action to get the item on specific index, and we will use the slot with item index as an index there. While recording this video, I also found out that I forgot to connect get output to the current item input of the set, so do it now. I will also fix it later in this video. Now we can make some more space here in case we need it. So let's select everything here and move it right. And I actually don't like how the slot with index item is connected here, so maybe it's better to just get it as a new variable there, new action, and connect it to the get action directly. We also have to replace the current index with the slot with item index, because the current index is also not defined outside of that for each loop. Now we can focus on the other part of the code we have ignored. This is the one which is executed when we didn't find any item with particular name and we were searching for the free slot. So get the free slot index and check if it's greater or equal 0. It means that we have found out some, and add the branch action and connect it to the false part of the previous branch action. If this branch is true, it means that we have some free space in the slot stored in the index, free slot index. We also have to replace the current index, but this time with the free slot index, because that's the ID of our slot. Now in the false part of this branch, we will simply add return node and keep the item edit unchecked, meaning that we were not able to add the item into the inventory, and this is called when the inventory is full. We also have to fix that missing connection between the get and set current item. Now if we click the compile and try to running the game, we can see that we can pick up the apple and we can move it around. And if we pick up another one, the grouping works correctly. The only issue is that when we pick up something, it appears on the right side of the inventory and we want it to appear on the left side. There is a simple fix for that. We just have to replace for each loop by reverse for each loop. And this will cause that the indexes we are storing in the variables are on the left side of the array and therefore on the left side on the inventory. We can verify that by running the game and checking that it's really the case. And we can see it works as expected. The last thing we will implement in this episode is dropping the item back to the game. For that we will create a new function in the inventory component and we will call it DropFromInventory. This function will have single input variable, so let's create a new input variable and set type to the integer, and the name will be slot index, and this will be index of a slot from which we are dropping the item. We will promote this slot index variable to local variable, so add the promote to local variable action and name the variable, for example, to index. Now we have to get the item structure from this inventory slot, so let's get the items array and use the get action to get what's in that array on the index position. And we will also store it in the local variable, so use the promote to local variable action to get result and name it item to drop. Don't forget to call this set action connecting the white lines, and next we can get this structure and use its break action to actually get the quantity out of it. In the right menu, hide the unconnected pins and only show the quantity pin. And for the quantity, we want to decrement it because we will be dropping single item from this inventory slot, so the quantity decreases by 1. Next, we want to check whether the new quantity equals 0, because if it does, we want to remove this item from the inventory completely. So add the equal condition and branch there, and in the true part, we will reset the inventory item to empty item. So we will use the get items array, and we will call its set array element action to set the item on the index position. So get the index variable there and connect it to the index input. And then we will use the make asItem action to create new empty asItem structure and simply connect this empty asItem structure to the item input. By storing this empty structure in the array, it means that there is no item in this inventory slot. Then we have to call the refresh inventory, so whatever is in the array is actually shown in the inventory slot widget, and connect it also to false part, because in case there is some quantity left, we just want to refresh it and show the right quantity. Now we will prepare the item we want to drop back to the game. So let's get the item to drop and set its quantity to 1, because we will be dropping exactly 1 item. So let's use the set members in asItem, and in the right menu we can find the quantity and show it and set it to 1. We can now call the spawn actor from class action to actually get the item back to the game. In the class, set the BPA base item as our base class for the items. And now we have to go back to the base item blueprint and change our item variable there, because the item variable is not exposed on spawn, and therefore we cannot call it from that spawn actor from class action. So click on that variable, hit the expose on spawn, compile it and go back to the inventory component. Now you can see that the item variable appears there, and we can set it to the struct out from the set members in asItem. We also have to call the spawn actor, and we also have to set the location when the items should be spawned. To get the location, we will get the player character, and in the player character we will call the get world location of the capsule component, which is where our character is currently located in the world. And we will simply connect the return value of this world location to the spawn transform, which will convert it from the vector to the transformation. So that's all for the DropFromInventory function, and now we have to call this function from somewhere, and we will do that in the inventory slot. So let's get there and add a new event called event OnDragCancelled. This is called when the item cannot be dropped into any widget, and in our case it means it's dropped in the game. In this event we also have the operation, and the operation is our drag drop operation. So let's use the cast to cast it to our inventory drag drop operation, so we can access the variables there. And from this inventory drag drop object we will need the from slot. So let's get from slot, and from this slot we should get the slot index. So let's use the get slot index action. And when we know the slot index, we can simply call our DropFromInventory function we have just created. So let's find the inventory component and call its DropFromInventory action, and connect the index from the get slot index to the index of the drop inventory, and we should be done in this function. Now hit the compile button, and we can test it out by trying running the game. And if we try to drop something, it appears in the game, so the game works as expected. So this is all for this episode, and I think our inventory prototype is good enough for now. So in the next episode we will implement the fighting animation and the roll animation and movement. So thanks for watching, please subscribe and see you next time.